Fluorescent garage lights flickering and unstable voltage readings can be frustrating. Let's explore potential causes and troubleshooting steps. Firstly, consider loose or intermittent connections. Check all connections in the garage, including outlets, fixtures, and wires. Secondly, examine for faulty wiring. Inspect the wiring for any damaged or loose wires that may be causing intermittent contact. Thirdly, investigate the ground fault circuit interrupter or GFCI. GFCIs can trip due to moisture or ground faults. Reset the GFCI in the garage. Fourthly, address overload or short circuit scenarios. Check if any heavy appliances or equipment are connected in the garage that may be overloading the circuit. Fifthly, scrutinize the neutral conductor. Even though a jumper was run from the ground rod to the neutral, there may still be a loose connection on the neutral side of the circuit. Sixthly, suspect faulty fluorescent fixtures. The fluorescent fixtures themselves could be intermittent and causing the flickering. Trying replacing the fixtures could solve the problem. Seventhly, look for voltage fluctuations. Check if there are any other electrical devices operating within the house that may be drawing a significant amount of power and causing voltage fluctuations. Lastly, eighthly, inspect for loose or worn wires in the panel. Inspect the main breaker panel for any loose or worn wires, particularly the neutral bus bars. Now let's delve into the troubleshooting steps in more detail. 1. Inspect connections. Visually inspect all connections in the garage and tighten any loose screws. 2. Check wiring. Use a voltage tester or continuity tester to check for any damaged or loose wires. 3. Reset GFCI. Locate the GFCIs in the garage and reset them if any have tripped. 4. Inspect circuit overload. Unplug or turn off any heavy appliances or equipment in the garage. 5. Test neutral connection. Use a clamp on ammeter to measure the current flow on the neutral conductor. If there is significant current flow, it could indicate a loose connection. 6. Replace fluorescent fixtures. If the fixtures are suspected to be faulty, replace them with new fixtures. 7. Monitor voltage. Use a voltmeter to monitor the voltage of the garage lights. If the voltage is fluctuating significantly, it could indicate a problem elsewhere in the electrical system. 8. Inspect main breaker panel. Turn off the main breaker and carefully inspect the wires in the panel. Loose or worn wires should be replaced. When working with electrical systems, safety is paramount. Always follow proper electrical safety guidelines. Turn off power to the circuit before performing any electrical work. Use appropriate tools and equipment for testing and diagnostics. If the problem persists or if you are not comfortable troubleshooting the issue yourself, consult a qualified electrician. Remember that voltage fluctuations can stem from various sources. If voltage measurements are erratic, focus the troubleshooting on potential shared circuits or high-demand appliances that could be creating voltage dips when they activate. A loose neutral connection, either at the panel within a junction box or at a device connection, is a frequent culprit in these situations. A jumper from the ground rod to the neutral will not reliably substitute for a solid neutral connection back to the service entrance. Check the voltage of various points in the circuit when the issue is actively occurring. Use a digital multimeter to measure the alternating current voltage between the hot and neutral, hot and ground, and neutral and ground. A healthy circuit will show approximately 120 volts between hot and neutral and hot and ground, and close to 0 volts between neutral and ground. Elevated voltage between neutral and ground suggests a problematic neutral connection. Intermittent issues are the most difficult to trace. Try to recreate the conditions when the problem occurs, such as operating specific appliances or turning on certain lights. This can help isolate the source of the issue. Also consider thermal effects. Electrical connections can loosen or corrode over time, and temperature changes can exacerbate these issues. If the problem seems to appear at certain times of the day, temperature fluctuations could be a contributing factor. Pay special attention to connections in areas exposed to temperature changes or moisture. When examining the breaker panel, look for any signs of overheating, such as discoloration or melting of the breaker or wiring insulation. Over time, breakers can weaken and trip at low currents than their rating, or they may fail to trip at all. If you suspect a faulty breaker, it is best to replace it with a new one of the same type and rating. Make sure to properly torque all connections in the panel to the manufacturer's specifications. Loose connections can create heat and lead to further problems. If the fluorescent fixtures are old, the ballasts inside them could be failing. Ballasts are responsible for providing the high voltage needed to start the fluorescent lamps and regulating the current flow. A failing ballast can cause flickering, dimming, or complete failure of the lamp. Replacing the ballast or the entire fixture might be necessary. Check the ampacity of the circuit wiring and the breaker size to ensure they are correctly matched. Using a breaker that is too large for the wire gauge can create a fire hazard. Consult the National Electrical Code, specifically Table 310.15b16 for the allowable opacities of insulated conductors. For example, a 15-amp circuit typically uses 14 American wire gauge copper wire, while a 20-amp circuit uses 12 American wire gauge copper wire. Aluminum wiring requires larger gauge sizes than copper for the same ampacity. Carefully inspect the wire insulation for any signs of damage, such as cracks, cuts, or abrasion. Damaged insulation can create a short circuit or ground fault. If you find any damaged wiring, replace the entire wire run, not just the damaged section. Consider the possibility of harmonic distortion in the electrical system. Harmonics are unwanted frequencies that can cause voltage and current distortion, leading to equipment malfunction and overheating. Nonlinear loads, such as electronic ballasts, variable frequency drives, and computers, can generate harmonics. A power quality analyzer can be used to measure the level of harmonic distortion in the system. If the distortion is excessive, a harmonic filter might be needed. Ensure that the grounding system is properly installed and maintained. A good grounding system provides a low impedance path for fault currents to return to the source, which helps to trip breakers quickly and prevent electrical shock. Check the ground rod connection and the grounding electrode conductor for corrosion or damage. The size of the grounding electrode conductor is determined by the size of the service entrance conductors according to National Electrical Code Table 250.66. A whole house surge protector can help protect electronic equipment from voltage spikes caused by lightning or other disturbances. Surge protectors divert excess voltage to ground, preventing it from reaching sensitive equipment. Install the surge protector at the main breaker panel for the best protection. Consider the age of the electrical system. Older wiring and equipment may be more prone to failure due to deterioration and wear. If the electrical system is very old, it might be time to consider upgrading it to meet current safety standards. Upgrading the system can improve safety, reliability, and energy efficiency. Use a non-contact voltage tester to quickly check for the presence of voltage on wires or equipment. This tool can help you identify energized circuits without having to make direct contact with the wires. However, always verify the absence of voltage with a multimeter before working on any electrical circuit. When working with electrical panels, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause severe burns and injuries. Wear appropriate personal protective equipment, such as safety glasses, gloves, and arc-rated clothing when working on energized panels. Always maintain a safe working distance from energized equipment. Follow lockout-tagout procedures to ensure that the circuit is energized before working on it. Lockout-tagout involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being accidentally turned on. Use a high-quality multimeter that is rated for the voltage and current levels you are working with. The multimeter should have a high impedance to avoid loading the circuit and affecting the measurements. Calibrate the multimeter regularly to ensure its accuracy. Use a clamp on ammeter to measure the current flow in a wire without having to disconnect it. This tool can be useful for troubleshooting overload or short circuit conditions. The clamp on ammeter measures the magnetic field around the wire, which is proportional to the current flow. Consider the possibility of electromagnetic interference or EMI. EMI can cause electronic equipment to malfunction or produce inaccurate readings. Sources of EMI include radio transmitters, cell phones, and microwave ovens. Shielded cables and filters can be used to reduce the effects of EMI. Check for the presence of rodents or insects in the electrical system. Rodents and insects can damage wiring and equipment, creating a fire hazard. Seal any openings in the building to prevent them from entering. Use rodent-resistant or insect-resistant materials for wiring and equipment. Consider the effects of humidity and moisture on the electrical system. High humidity can cause corrosion and reduce the insulation resistance of wiring and equipment. Use moisture-resistant materials and seal any openings to prevent moisture from entering. Install dehumidifiers or ventilate the area to reduce humidity levels. Check for the presence of asbestos in older electrical equipment, such as wiring, insulation, or panel boards. Asbestos is a hazardous material that can cause lung cancer and other diseases. If you suspect the presence of asbestos, contact a qualified asbestos abatement contractor to remove it safely. Consider the use of energy-efficient lighting and appliances. Energy-efficient lighting and appliances can reduce energy consumption and lower electricity bills. LED lighting is a good choice because it is energy-efficient, long-lasting, and produces less heat than incandescent or fluorescent lighting. Use a power quality monitor to track voltage, current, and other electrical parameters over time. This tool can help you identify intermittent problems or trends that might not be apparent with a single measurement. The power quality monitor can record data for days, weeks, or even months. Consider the use of a backup generator to provide power during outages. A backup generator can keep essential equipment running, such as refrigerators, freezers, and medical devices. The generator should be sized to handle the load and should be installed by a qualified electrician. Use a ground fault circuit interrupter or GFCI protection for all outlets in wet or damp locations, such as bathrooms, kitchens, and garages. GFCI protection can prevent electrical shock by quickly interrupting the circuit when a ground fault is detected. Test GFCI outlets monthly to ensure they are working properly. Install arc fault circuit interrupters are sized to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. A size detect arc faults and quickly interrupt the circuit, preventing a fire from starting. A size are required in many areas by the National Electrical Code. Consider the use of surge protection devices or SPD to protect against voltage surges. Voltage surges can damage sensitive electronic equipment. SPD divert excess voltage to ground, preventing it from reaching the equipment. SPD should be installed at the main breaker panel and at individual circuits. Consider the use of uninterruptible power supplies or a UPS to provide backup power for critical equipment. UPS provide instantaneous power in the event of a power outage, preventing data loss or equipment damage. UPS are commonly used for computers, servers, and medical equipment. Use a thermal imaging camera to detect hotspots in electrical equipment. Hotspots are areas of excessive heat that can indicate loose connections, overloaded circuits, or failing components. The thermal imaging camera can help you identify problems before they cause a failure. Consider the use of a smart home system to monitor and control your electrical system. Smart home systems can provide real-time data on energy consumption, voltage, and current. They can also allow you to control lights, appliances, and other electrical devices remotely. When working on electrical equipment, always wear appropriate personal protective equipment or PPE. PPE includes safety glasses, gloves, and arc-rated clothing. PPE can protect you from electrical shock, burns, and other injuries. Always follow the National Electrical Code or NEC and local electrical codes when installing or repairing electrical equipment. The NEC provides detailed requirements for safe electrical installations. Local electrical codes may have additional requirements. Consider the use of a qualified electrician for any electrical work that you are not comfortable performing yourself. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you troubleshoot complex electrical problems. Use a wire stripper to remove insulation from wires without damaging the conductor. The wire stripper should be sized to match the gauge of the wire. Avoid using a knife or other sharp object to strip wires, as this can damage the conductor. Use a crimping tool to securely attach terminals to wires. The crimping tool should be sized to match the size of the terminal. Avoid using pliers or other tools to crimp terminals, as this can result in a loose or unreliable connection. Use a fish tape to pull wires through conduit or walls. The fish tape is a flexible metal or plastic strip that can be used to guide the wires. Avoid pulling wires too hard, as this can damage the insulation. Use a conduit bender to bend electrical conduit. The conduit bender should be sized to match the size of the conduit. Avoid bending conduit too sharply, as this can restrict the flow of wires. Use a torque wrench to tighten electrical connections to the proper torque. The torque wrench should be calibrated to the correct torque value. Over-tightening or under-tightening electrical connections can lead to problems. Use a level to ensure that electrical equipment is installed level. Leveling electrical equipment can improve its appearance and performance. Avoid installing electrical equipment in areas that are prone to moisture or flooding. Moisture and flooding can damage electrical equipment and create a safety hazard. Use a surge protector to protect electronic equipment from voltage spikes. Voltage spikes can damage sensitive electronic equipment. The surge protector should be installed between the equipment and the power source. Avoid overloading electrical circuits. Overloading electrical circuits can cause the breaker to trip or the wires to overheat. Use a power strip with a built-in circuit breaker to protect against overloads. Use a qualified electrician to install a new electrical service or upgrade an existing one. Installing or upgrading an electrical service is a complex task that should be performed by a qualified electrician. The electrician will ensure that the service is installed according to code and that it is properly grounded. Use a ground fault circuit interrupter or GFCI to protect against electrical shock. A GFCI will trip if it detects a ground fault, which can prevent electrical shock. GFCI outlets should be installed in bathrooms, kitchens, and other wet areas. Use an arc fault circuit interrupter or RFSI to protect against electrical fires. An RFSI will trip if it detects an arc fault, which can cause a fire. RFSI breakers should be installed in bedrooms and other areas where people sleep. Use a smoke detector to alert you to the presence of smoke. Smoke detectors should be installed in every bedroom and on every level of the home. Test smoke detectors monthly to ensure that they are working properly. Use a carbon monoxide detector to alert you to the presence of carbon monoxide. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed on every level of the home. Test carbon monoxide detectors monthly to ensure that they are working properly. Use a fire extinguisher to put out small fires. Fire extinguishers should be installed in kitchens and other areas where fires are likely to occur. Learn how to use a fire extinguisher properly before you need to use it. Have your electrical system inspected by a qualified electrician every few years. A qualified electrician can identify potential problems and make recommendations for repairs. Electrical inspections can help to prevent fires and other electrical hazards.